This is Ed Robinson of Kensington College, continuing our lessons on C++ in particular. Today we'll be talking about arrays. What is an array? An array is a collection of items which are of the same type, either all integers or all doubles. That's the meaning of type, or indeed strings, etc. But they all must be the same. So let's start off by talking about one-dimensional arrays. So let's start off by making a one-dimensional array which will hold integers. So I'll say therefore it's going to hold integers. Then I just need to make up some name for the array, and then let's say the array is going to contain 4 elements, and then we might initialize the elements as well. We don't have to, but so we have here an array of integers. So I'll just emphasize that the things inside the array must either be all integers, all doubles, all strings, and so on. We've talked about structures, and a structure is something which can hold data of different types, but an array can't. An array holds stuff of the same type. So let's say we want to access our array, and I might want to just print out an element. Well, if I want to print out the first element, first of all I need square brackets when I'm printing out an element, and I'll just put an end line there as well. And now if I want to print out the first element, it in fact is element 0. This can be a little bit confusing and a bit hard to get used to, but we need to get used to it because that's the way that C++ works. I'll just start off by printing that element out, and that should print out the first element 1, which is element 0. Now that means that this is element here is element 1, and this is 2, and this is 3. There is no element 4. Now that can be a bit confusing because we've said here 4, but element 4, if I put a 4 here, it would give an error, and it's a very dangerous thing to do. Actually, you're messing around with memory outside of the range of the array. But that 4 means there are 4 elements, but element 4 doesn't exist. The biggest element that you can have, the biggest index you can have, is 3, which gives you therefore element 3. Element 3, which indeed would in this case be 4, the element 4. Indeed, it's clever enough to know that there are 4 elements, so we don't really need this 4 if we are initializing the array. But if we're not initializing it, then we do need the 4. So if I were to get rid of that, you'll see that that should complain about, and it'll give an error. Incomplete type is not allowed. So you need therefore to specify how many elements there are in the array. That is, if you're not initializing it. So let me get those initializing elements back again. What I'll do is put a breakpoint down to here, and then I will run the code. It's very interesting to look at these locations in memory. We really have to concentrate on what is the meaning of that age there. Age, in fact, is another type of variable which will hold an address to where the array is. Let's see what that means in real money. Take a look at the memory. Now to open up, I've run the program down to a breakpoint down to here, and I could take a look at these windows, which is if you go through the windows, we can take a look here at the locals window and also the memory window, and these are they here. So let's just see what they mean. So I'm at this point here at the moment, obviously, so I'll do an F11 to single step. Now notice that I've got here my array, and indeed it's quite nicely showing here in the locals windows. That's all you usually need to do. But from a learning point of view, I'd like to go and take a look at these in memory. Now we need to take a look at that address, which is 0031 and so on. What I'll do is to put that address into the memory window, which I'll do here. So I'll very carefully type that in. It's 0031 F9 B4. Now if I've typed it correctly and press enter, you can see the array has appeared here. So I'll just bring that window down a bit to show you that it's 4 bytes here. This is the elements which are stored in the array, starting at this address here. Now this address here is the address of the array. That address is stored in age. Now age is a special type of variable which we call a pointer, and it points, it holds the address of that element. Now this is very convenient when we're passing an array to a function, for example, because when we pass to a function we don't want to pass all the individual elements necessarily. We want to pass just the address of the array, and then the function will know where to go and find it. So we have here the array is in this memory location. There's no point in duplicating it elsewhere in the memory. We just need to tell it where the array is going to be. So you must understand that age is an address of the array. If we wanted to print out the address of age, then we could try so that if I run that down to the breakpoint, notice the address now of age. I'll just press F11 to single step, and you'll notice the address wasn't the same as last time, so these things move about a bit in memory. But I'll just take a look at my array once more and carefully type in the address. It's quite different actually from last time. 001 DF7 F0, which you may just be able to read down here. But if I press enter, you'll see that my array appears. Now if you could just remember this address here, which is 1DF7F0, because if indeed I run my program further, and don't forget we need to use F10 if we're coming against these couts to jump over that print routine. So I'll press F10, and you'll notice that address that I've just printed out, you see, is the same as this address. You might just be able to see that the address there is this address here. It's the same. So I've printed out, when I print out age, I'm printing out an address of the array. So don't forget how we printed out the individual elements. For example, if I print out the first element, element 0, then that would just give me the 1 as we did before. But what about using this, an ampersand? Now ampersand means the address of, so the address of the first element. Now can you see what's going to happen here? Well, you'll get exactly the same result for this as this. So these things mean identical things. Let's just try that out without the breakpoint, and when I run that you'll see they give exactly the same result. So remember, age is the address of the first element, and this indeed is being more explicit to say that this means it's the address of the first element, in other words the address of 1 in memory. So these both give the same thing. So with that knowledge, let's talk about how we might send our array to a function. Let's say we'll call our function print, and we want to print out all the elements in the array. So you might have something like that, and then our print function is not going to return anything. And don't forget, we need to have a prototype for this as well. Don't forget the semicolon and the prototype. So now we need to make our, so we need to work out how to call our function, but what do we actually pass to the function is the question. What goes in here? Well, the answer is that we just need the age, which is the, remember this is the address of the first element of the array, or the address of the array indeed. So we can therefore use that to just pass the address, and that's all that the print function will require to know where the array is. So the print function needs to know where the array is. Well, it needs to be passed to some variable. We'll call it something similar. You could call it AG, or indeed you could call it AGE, but it might just, as long as you understand that these and these are going to be two different variables, then you could call it AGE as well, but for the moment I won't. Well, it's got something to do with integer. It's going to contain integers, but now that doesn't, something going wrong here at the moment, because what we're doing is we're passing an array to passing the address variable, and we're passing it to this variable, which is an integer. Well, okay, the address is an integer, but it's a different type of integer. So we can't just use that. We have to say that this is also a pointer to the start of the array. And how do we define such a variable? Well, there's a way of using pointers, but we haven't come to pointers yet. So what we need to do is use this square bracket notation to indicate that AG is an array containing integers, which needs to be the right way around. So now AG is indeed a pointer to an array, as indeed this is here. So I mean, that is, I must admit, that is a little confusing, but that's the way it is. You need to remember how to do that, how to declare this as a variable which will hold the address of the array. So then we might like to simply, in our print function, we might want to print out the elements, just one of the elements for the moment. Then we will just, for example, print out the first element once again. And we really must remember to change our update the prototype, if you like. And then when we run that, it indeed prints out the element 1, which is the first element in the array. So just to summarize, we've passed the address of the array to a variable which can hold an address. How do we know that? Because we declare it to be such a variable. Then we can access the individual elements of the array. You might like to put a for loop in there, for example. That would be interesting, to print out all of the elements of the array. We'll just comment out that bit of code for the moment, and we'll perhaps come back to that, how we print something out, because before we do that, I want to consider a two-dimensional array. So we could say this is a row of data. What I'll do is provide another row of data. But I need to enclose those in a pair of braces themselves. So here we have created a two-dimensional array, but there's something going wrong here, that we need to say that we've got, indeed this time I need to say that I've got two rows. So I need to indicate that eventually, and therefore I have now defined a two-dimensional array. We could actually leave out the 2, because it's clever enough to know there are 2 rows, 1, 2 rows, but it's not clever enough to know that there are 4 in each one. So I need to I will leave the 2 in, but I don't have to. So what I'll need to do now is I want to work out how to access an element of the array, and for that we'll be using 2 indices. Now 0, 1, what does that mean? Well, let's find out for a start. If I run that, then I will get the first, well, I will get this element here. Now, why do I get that element there? Because this 0 here, meaning it's the first, consider this as a row of elements. If I had a 1 in that position, it would be this row of elements. What does the 1 represent. Don't forget, this goes from 0, 1. Even though it's 2 here in the first dimension, this only goes from 0 to 1. So if you put a 2 there, you'd get a terrible error. So I've got, this is my first row, and what does this mean here, this 1? This 1 means, well, if you take the first row, it's the second element. Second, a bit confusing, remember it starts at 0, so this would be element, if I put a 0 here, this would be this element here. So a 1 means it's the second element, and that's why I get the printout of element 2. Well, let's say that I want to pass my array to a function similar to what we've got here. So I want to call the function and pass my array, and I want to work out how to do that. Well, it might again be instructive to take a look at the memory windows. So I will run my code down to here, to this breakpoint. So if I run my code down to this breakpoint, and then I've pressed F11 to go past that, so the array has been initialized. If I take a look at the array in memory, there it is. Notice it's stored sequentially, and if I look in the locals, it's perhaps a bit more better set out. You can see the first row here in the first column of so looking in the locals. But for instruction purposes, what I've done, I've taken this memory address of the first element of the array, and I've typed it in here more or less, and it's given me the array of numbers. So once again, exactly the same as for a one-dimensional array, age is the address of the first element. It's the address of the array. So that will mean that if I want to pass my array, I can do exactly the same as I did before and pass it like that. So that's just passing the address of the array, and that's sufficient to know where the memory is located in where the array is located in memory. So my print function is going to know where it is. So I'll just uncomment that. I need to modify it a little bit to accept a two-dimensional, or the address of a two-dimensional array. So what I want to do is to print out an element. You can print out all of the elements really, but I'm going to do my printing in the print function and change the name of the variable for the moment. Now this needs to be modified here to say that we're accepting the address of a two-dimensional array. So I'll need to tell it that that's indeed what it is. And don't forget, I need to modify the prototype as well. Don't forget the semicolon. So I'll just take the breakpoint off there and run the code. And indeed, it prints out the element 2 as before, where element 2, don't forget, is 0, 1, means that's the, once again, is the first row, the 0, and then the second element corresponding to the 1. So that's why we get the 2 printed out. Well, I must admit that can be a bit tricky, but the main thing is to remember that this is an address of an array. So once you pass to a function, you're passing the address, and then that function has access to all of those elements. But you need to qualify and say what sort of a thing this is. There's no use just saying it's an integer. You need to say what it is. It's an address of a two-dimensional array which contains 2 by 4, and inside ultimately are integers. As an application of arrays, we might consider matrices. Now matrices, we're really getting on to the subject of mathematics really, matrices, but it's not too difficult to understand. What is a matrix? A matrix is usually denoted with square brackets like this mathematically, and it's a box of numbers. So the numbers correspond. So what I mean is, let's say that this is all the sales of IBM shares, and US Gas are these share prices, and Custom A bought 2 IBMs and so on. Now that we might now consider that to be the purchases of February. And what if we wanted to, or January, and we wanted to add together the elements from January plus the elements of February and see what the total for those 2 months were. So in here we've got customer A bought 3 IBM shares and so on for the two months indeed. So what we could do is to try and from C++ we could see how we could, for a start, make a matrix and then add them together. So we could start off by giving a matrix a name M1, and we're going to have just a 2 by 2 rows and 2 columns. So that should declare and define one of our matrices, M1. It might be nice to have a general routine to print out our matrices, so as we want to pass our matrix to a print function, for example, that will print out all of the elements in the array. Now, how do we declare this variable here? In the same way that we declared the previous, we need to int, and then M has got to be a 2 by 2. And then we want to print out, we'll print out all the elements in the array. We could use a for loop, or we could just set them out across as I'll show you now. So I might like to print out my array across set width that we're using. So I need to include and I also need to modify my prototype. Now if I were to run this, let's see what happens. It should print out just the first row so far of my matrix. So far you can see what we've done here with the set width. We've set a field width of 4 characters to print the 1, and then the first element to print is 0, 0, which, remember, 0, 0 is the first element, which is the 1 if you look above here. And then we've made another field of 4 width, and then 0, 1, 0, 1 of course being the first row and the second element. That's the first row, so the 2 is the first row and the second element is indeed that 2. But really the main thing to focus on is how we actually pass the array. Here this was the address of the array which was passed, and it's passed to a variable which indeed itself is an address, which is made an address. How do you make an address? You declare it thus. Okay, so we could print out the second line of the matrix, and so we're going this time element, that'll be element 1, 0, and finally 1, 1. And if we were to run that, then we should get the complete matrix printed out in a mathematical way, mathematically presented way. Incidentally, if we were not to initialize an array, then we could do that. We could leave those elements off if we're not initializing, but you must therefore specify what. If you don't specify there, you'll get an error. So you do one or the other. So you can here and then, but remember also that you could actually leave out that originally specified as well. It's clever enough to know that there are 2 rows, but not clever enough to know there's two columns in each row. So as an exercise, it'd be a good idea to write another function, an add function, which should add together the 2 matrices. So I'd need to define another matrix, call it M2, and change the elements in it if you like. and you need therefore to be able to call this add function and pass the matrix, and you need to be able to work out how to add the individual elements together. So we need another matrix which we could call M3, and we need to initialize that with nothing in it, and then that could hold the result of adding M1 plus M2, just like we were talking about when we added together the two matrices. So in here, so you need to individually add the 1 plus the 2 to give 3. So that's element 0, 0 plus element 0, 0 gives element 0, 0 of the respective matrices. So we will indeed need another matrix to hold the result. We'll call it M3, which will be the sum of the other two matrices. And we're therefore going to add together the two and get the result. So we need to pass, this time we need to pass two matrices. To our add function, and therefore we need to accept two matrices. I shouldn't really use the same names, but I will. But just keep in mind they are separate variables. I'll just move this code up a bit so we can see it. And don't forget, we need to include our prototype eventually. So that indeed will pass. I've got my two matrices here, M1 and M2. Now, how am I going to deal with M3? Well, perhaps I could pass M3, and remember that matrices are here being passed by reference. So whatever we do to the matrix will be permanent. So it's therefore, now I shouldn't be using M1, M2, M3 once again, but I should really be using another like A, B or C or something like that, but for the moment, okay. And don't forget that we need to also have our prototype as well, and don't forget the semicolon. Now that looks a little bit dangerous there, so I'll initialize M3 as well, and I'll be passing by reference. Now I need to work out how to add together the array. So I've got my first, I need to add them element by element. So the first element of M3 needs to be put equal to the first element of M1 plus the first element of M2. So that just should alter the first element. We could actually just try that out and see if that indeed does that. So we see that the first elements are being added together. That's the one here has been added to the one here, and the result has been placed in here. So now I need to do them for the other three elements. I'll just stop the program and so element 0, 1, and then the ones, 1 zeros, and finally the 1 ones. so that when we run that, we get the M3 printed out, which is indeed the sum of the two matrices. So we've added together the 1 plus 1 to give us the 2, etc., element by element. It might be interesting to put a for loop in here, the 2, because we might have a 3 by 3 matrix, for example, and they're known, for example, 1,000 by 1,000 matrix. When they were designing Concord, the profile of Concord, they needed to solve 1,000 equations, and they made a 1,000 by 1,000 matrix. So it's got very useful applications.